Welcome back to Science Modernizers. Welcome back to this video. Today we are going to see a question on further pure mathematics, and as seen on the screen, the official partner of the CIMO 413 team is Objective Corporation. Objective Corporation is a national preparatory center which prepares students to go in for national competitive entrance examinations. So for all those interested in going in for competitive entrance examinations in Cameroon all over the national territory, you can contact us through the number on the screen. And also it also offers facilities in obtaining scholarships abroad and to study abroad at no cost. Okay, so let's get started with our video. If you are not yet subscribed to our channel, please do well to subscribe for more videos. So let's launch with the problem. Okay, let's get a question. So the question reads, we begin with the first, which says, solve the linear congruences. 3x is congruent to 1 mod 5 and 5x is congruent to 2 mod 7. 7 marks. B. Given that f of x is equal to, we have 3 root 4x squared plus 2x plus 1 plus 2x minus 3 if x is less than or equal to 0. We have x into x minus pi on 4 if x is between 0 and pi on 4. And we have negative cos x plus sin x plus 2 divided by 3x plus 1 if x is greater than or equal to pi on 4. Now the question says, Roman 1, determine the limit as x approaches negative infinity of f of x, 4 marks. Roman 2, show that for all x greater than or equal to pi on 4, f of x is between lies in between 0 and 2 on x inclusive, and hence deduce the limit of f of x as x approaches positive infinity. And lastly, study the continuity of f at x equal to pi on 4, 3 marks. So you can pause the video and you give it a try, then come back and verify your solutions. Okay, so we are going to begin with a question on congruences. Okay, so to begin with, we have that 3x is congruent to 1 mod 5. So this simply means that x will be congruent to 2 mod 5. So what did I do? I had to multiply all through by the inverse, the multiplicative inverse of 3. So the multiplicative inverse of 3 in mod 5 is 2. Since if we take 3 times 2 is going to give 6, and the modulo 5 will be congruent to 1 mod 5. So it means that the multiplicative inverse of 3 will simply be 2. So if I multiply all through by the multiplicative inverse, it means that x will be congruent to 2 modulo 5. And from here, it means x will be equal to 2 plus a certain 5k, where k is a given integer. So we'll call that equation 1. So we do the same thing with the second equation. We have 5x is congruent to 2 modulo 7. Now the multiplicative inverse of 5 in mod 7 will simply be 3, since 5 times 3 gives 15, and if you take 15 divided by 7, we are going to have 2 remainder 1. So since the remainder is 1, it means the multiplicative inverse of 5 will be 2. So if I multiply all through, so it will be 3. So if I multiply all through by 3, I'm going to have, which is the multiplicative inverse of 5. So then I'm going to have that x will be congruent to 6 modulo 7. So I'm going to call that equation 2. Now I'm going to substitute equation 1. So if I replace equation 1 in equation 2, it means I'm replacing x to be 2 plus 5k. So I will replace it here in this x. So it means I will have that 2 plus 5k will be congruent to 6 mod 7. So I will send 2 on one side. So it means that 5k will be congruent to 6 minus 2, which is 4 modulo 7. And from here, if you still multiply also by the multiplicative inverse of 5 in modulo 7, then we are going to have that k will be congruent to 12 mod 7, since the multiplicative inverse of 5 in mod 7 is simply 3. So if you multiply by the multiplicative inverse of 5, which is 3, we get that k will be congruent to 12 mod 7. But since 12 is greater than the modular number, then we get that we subtract 7 from 12, we are going to have that k will be congruent to 5 in modulo 7. Now from here we can write this using the same notation. It means that k will be equal to a certain 5 plus 7l, where l is simply given the integer. Now if we replace k in equation 1, what are we going to get? We have that x will be equal to 2 plus 5k. But what is our k? Our k is 5 plus 7l. And so if we simplify, this means x will be equal to 25 plus 35l, from where we can see that x will be congruent to 25 modulo 35. So that is the solution of the linear congruent, the two congruent equations. So this can be verified. So if you take these values, the value of x is 27, and you plug in any of these, their remainder should be 1. So what do we have? If you take, for example, 27, if you take 3 times 27, it will give you 81. So if you take 81 divided by 5, you will see 81 divided by 5 will go 16 times remainder 1. So you see the remainder is consistent and it will satisfy both. So if you also take 27 and you replace in the place of 5, so that will be 5 times 27, so it will give you 135. If you divide by 7, you are going to have a remainder of 2, so it will go 19 times remainder 2. So it means the solution to the two system of simultaneous congruent equations will simply be x will be congruent to 27 mod 35. Okay, there are alternative ways of solving this, so this is just one of the procedures. Okay, so let's pass to the next question. Now the next question says we have to evaluate the limit. So if we have a function, first of all, which is defined on given interval, so we have 3 times the square root of 4x squared plus 2x plus 1 plus 2x minus 3 if x is less than or equal to 0, and so on and so forth. Now we want to deduce the limit as x approaches negative infinity. So we see that negative infinity will be found in the domain or in the range where x is less than or equal to 0. It cannot be found here, neither can it be found here. So we are going to evaluate the limit at negative infinity. It suffices for us to evaluate the limit of 3 root 4x squared plus 2x plus 1 plus 2x minus 3. Now what do we get? If I factor out inside the square root sign, or if I factor out x squared, that's the highest degree of x, what do I get? I will have that this will be equivalent to the limit as x approaches negative infinity of 3 times the absolute value of x times the square root of a factored out x squared. So that will be 4 plus what will be left here will be 2 on x plus 1 on x squared, then plus 2x minus 3. Now how do I deduce that the limit is positive infinity? Notice I wrote this absolute value of x just for us to note that each time we factor out x squared from the square root is the absolute value of x, so it can either be positive or negative. Now notice that our x is negative. Our x is negative, and so if x is negative, we are going to consider this x to be negative. Now as x approaches negative infinity, 2 on x will tend to 0, 1 on x squared will tend to 0, so we'll be left with the square root of 4, which is 2. Now that 2 times 3 will be 6. Now the absolute value of x here will be negative, so we'll take 6 times negative x, that will be negative 6. Then we add to plus 2, so that will be negative 4x minus 3. Now since x is approaching negative infinity, when you replace it at the level of negative 4x, you see we are going to have something positive, and a very positive large number minus a small constant like 3 will still be a positive large number. So therefore this limit approaches positive infinity. Okay, so let's go to number Roman 2. We want to show that for every x greater than or equal to 4 pi on 4, then f of x is between 0 and 2 on x inclusive. So to begin with, we are going to begin by the bounds of cos x. Since cos x is a bounded function, we know that cos x lies in between negative 1 and 1, and also it means if I multiply all two by a negative sign, our inequality signs will change. So negative 1 will come here and the inequality signs will change, but when we rearrange, we see that cos x, negative cos x, will still lie between negative 1 and 1. So we'll call that equation 1. And similarly, the sine function can be bounded it is positive sin x. So for that mistake, so sin x will also lie between -1 and 1, not negative sin x. So please, that negative is not there, since here we don't have a negative sign. So we have that sin x will be bounded between -1 and 1, and that will be called equation 2. Now if I sum both equations, you see that I'm going to sum their lower boundaries and I'm going to sum their upper boundaries. So it means that negative cos x plus sin x will lie between -2 and 2, since if I sum -1 and -1, I get -2, and if I sum 1 and 1, I get 2. Now we are going to create this function from this inequality. So if I add 2 on both sides, what do we get? We have that -2 plus 2 will be 0, and negative cos x plus sin x plus 2 will be less than or equal to 2 plus 2, which is 4. And from here, since 3x plus 1 is positive, because x is greater than or equal to pi on 4, which is a positive number, I can divide all 2 by 3x plus 1 with no fear. Now if I divide 0 divided by 3x plus 1 will still be 0, and negative cos x plus sin x plus 2 divided by 3x plus 1 gives my f of x, and now 4 divided by 3x plus 1. So this division is possible because 3x plus 1 is strictly greater than 0, so the signs of my inequalities are unaffected. Now, but we have to prove that this is true, that this inequality is true for x greater than or equal to pi on 4. And we see that for x greater than or equal to pi on 4, for all x greater than or equal to pi on 4, 4 divided by 3x plus 1 will always be less than or equal to 2 on x. In other words, 2 on x will be greater than this. So we can choose any value. For example, let's say 10. Now let's not even go too far. Let's just say a value like 3. So you have 2/3 and you have 4 divided by 3 times 3, 9 plus 1, 10. So you have 2/3 and 4 on 10. You see this is 0.4, and 2/3 is 0.6666666, and so on and so forth. So you see it will be true for all values of x that will be greater than or equal to 4. So using this inequality and replacing at the level of the general inequality we obtain here, since this is not what is required of us, what do we have? We now see that our f of x will be between 0 and 4 divided by 3x plus 1, but this 4 on 3x plus 1 is less than or equal to 2 all over x, and we can now deduce that since this is less than or equal to 4 over 3x plus 1, which is also less than or equal to 2 all over x, then it means that our f of x will lie between 0 and 2 all over x as required. Now we have they said hence deduce the limit as x approaches positive infinity of f of x. So we are going to use the squeeze theorem. Now if we evaluate the limit as x approaches positive infinity of f of x, it means we are going to evaluate the limit at the left bound and the limit at the lower bound and the limit at the upper bound. But since the function at the lower bound is 0, the limit as x approaches positive infinity of 0 is 0, and we are evaluating the limit of f of x, and that will be equal to the limit as x approaches positive infinity of 2 on x. Now I forgot to include the limit sign here. So what do we have? We evaluate the left limit and the right limit. So clearly the left limit gives 0, and the right limit as x approaches positive infinity 2 on x return to 0. And what do we have? You see that the limit as x approaches positive infinity of 0 is equal to the limit as x approaches positive infinity of 2 on x, which is equal to 0. And so what then can we deduce from the squeeze theorem? We can deduce that since the limit of the left hand of the lower bound and the limit of the upper bound are similar, then it means that the limit as x approaches positive infinity of that function at the point, at positive infinity will definitely be 0, since both limits are the same. Now the Roman 3 part says we should study continuity of f at x equal to pi on 4. So what are we supposed to study? It suffices for us to evaluate if the limit as x approaches pi on 4 from above is it the same as the limit as x approaches pi on 4 from below. Now pi on 4 from below, we are going to consider the function x into x minus pi on 4, since that's x plus pi on 4 from below, and pi on 4 from above, we are going to consider the second function. Now we are going to replace pi on 4 on our function, and if we replace pi on 4 in f of x, what do we have from above? We replace it here. We have that cos pi on 4 is negative root 2 on 2 is root 2 on 2, so negative root 2 on 2 sin pi on 4 is root 2 on 2, sort of gives 0. We have 2 divided by 3 into pi on 4 plus 1, in which if you simplify we have 8 divided by 3 pi plus 4. And then now we also see that if you evaluate the limit as x approaches pi on 4 from below, we have 0, since we pi on 4 times into pi on 4 minus pi on 4, which is 0. Now what do we see? We see that the left limit is not equal to the right limit, and hence f is not continuous at x equal to pi on 4. So that is what was entailed for you to do in this problem situation. Thank you very much for watching, and if it is your first time in our channel, please do not forget to like, share and subscribe. See you in the next video.